Hello! We are going to talk about a great topic today, inverse trig derivatives. So there's a little bit of memorizing here, and we're going to start off though with a little bit of review from Algebra 2 about our inverse trig graphs and how to evaluate inverse trig functions. Okay, what you're looking at here are the three inverse trig graphs. Oftentimes we use arc to represent inverse. So when we say y equals arc sine x, it's the same as saying y equals inverse sine x. And if you look here, you can see that we have the three graphs. This is the graph y equals arc sine x. You can see that things are a little bit different when you look at these graphs from our normal sine and cosine. And that's of course because inverse means we switched our domain and our range. So whereas normally we have pi on our x-axis, we now have it on our y-axis. So you can see here that this arc sine graph spans on the y-axis from negative pi over 2 to pi over 2. And then on the x-axis, it spans from negative 1 to 1. Okay, you can see here our graph of y equals arc cosine x. And that is from 0 to pi on the y-axis and from negative 1 to 1 on the x-axis. Y equals arc sine x and y equals arc cos x, both are graphs that are functions. They do not have any asymptotes, and we're going to talk a little bit more about them in a second. Y equals arc tan x here, okay, you can see this graph spans from negative pi over 2 to pi over 2 as well. But hopefully you can see that we have horizontal asymptotes at negative pi over 2 and pi over 2. And so the graph gets infinitely close here to those values but does not touch it. Okay. The graph though, the arctangent graph, goes on forever and ever to the left and the right. It doesn't stop like our arc sine and our arc cosine graphs do. Okay, now we're going to talk about each one of these functions individually and just kind of break them apart and also do some evaluating. Stuff that we've done in the past, but we're just going to kind of bring it back to the forefront of your mind and make sure that you know how to evaluate an arc sine, arc cos, or arc tan function. Okay, so we're going to start with our arc sine graph, our arc sine function, okay, and you can see here that it's called y equals arc sine x, or as I said, we can call it y equals inverse sine of x. All right, now I just want to kind of review for you for a second where this graph comes from. And like I said, our x-axis here is from negative 1 to 1. And the reason why is because if you think about the sine graph, the y equals sine of x, hopefully you remember that it looks like that. And the maximum height, the maximum y value is 1, and the minimum y value is negative 1. Well, if we're switching our domain and range, that now becomes the min and max on the x-axis. Okay, and then the y-axis, well, if I were to take this graph, y equals sine x, and flip it over the line y equals x and do its inverse, what's it going to look like? Well, you can see here that I see a part of it in the graph that's given to me, but what does the rest of it look like? Well, if I were just to graph it, I might see something that looks like this. Okay, and so on. And it obviously would go on forever and ever. Well, if you look at that though, there is a problem. And hopefully you're recognizing that the way that that graph is graphed, it is not a function. And so it doesn't pass the vertical line test, which is why what we do is we take it and we truncate it. And we stop here and we stop here. And we say we are only going to focus in on this part of the graph. Because if I do that, I have all values from negative 1 to 1 covered, and it remains to be a function. And so that's what they've done. They've truncated the function, and so we're only looking at the values from negative pi over 2 to pi over 2 on the y-axis. All right, so having said that and kind of reminded yourself of that and where that arc sine x graph came from, the domain then is from negative 1 to 1. And the range is from negative pi over 2 to pi over 2. Okay, we are going to move on to evaluating some arc sine function questions. And so in order to do that, I first want to kind of just start off by reminding us about some vocabulary. So if I say sine of pi over 4, on the regular sine graph, when I evaluate sine of pi over 4, I know that the answer is radical 2 over 2. Whether I use my unit circle or have that memorized, sine of pi over 4 is root 2 over 2. When we do this, what we are taking the sine, cosine, or tangent of, is our angle. And this, the root 2 over 2, is our value. Okay, well, when we do inverse sine or arc sine questions, those are reversed. And so what you are going to be asked is the arc sine of the value, and your answer will be an angle. Now you want to be cognizant and thoughtful of the fact that our values, our answers, have to fit between these two extremes, negative pi over 2 and pi over 2. So our answer is going to be an angle, and that angle has to be between negative pi over 2 and pi over 2. And so when we're asked questions, we just need to think about that and make sure that that's the answer we're giving back. Okay, so let's just try another one. If I asked you what was the arc sine of 1/2. So what is this asking? This is saying the sine of what angle is equal to 1/2. Well, hopefully you know that that's 30 degrees, which in radian measure is pi over 6 radians. Okay? Now, what if I were to ask instead for the arc sine of negative 1/2? And this is where it gets a little tricky. Because remember, we said that our answers has to fit between negative pi over 2 and pi over 2. If we use our graph here to kind of help us out, it's saying arc sine of negative 1/2. Well, negative 1/2 is right here on the graph. And you can see that the value is right there. Now you can tell from where the graph is located and that the y value at that point would be a negative value. And so we are in fact looking for a negative answer. And so the nice thing is if the arc sine of 1/2 is pi over 6, the arc sine of negative 1/2 is going to be negative pi over 6. All right, let's move on to arc cosine. Okay, the same thing happened with the arc cosine graph or the inverse cosine graph. They took the entire graph for y equals cos x, they flipped the x and y and they regraphed it, and then they truncated it so that it was a function. So this time our domain is between, again, negative 1 and 1. Those are the x values. The range, the minimum is 0 and the maximum is pi, so between 0 and pi, which would be in our first and our second quadrants. So when we are evaluating arc cosine questions, we are giving answers in the first or second quadrant. All right, so let's start off with arc cos of 1. Okay, so arc cos of 1. Now, what is this asking? This is say the cosine of what angle is equal to 1. And you can even use the graph here to tell that when x is 1, y is 0. And of course, you should keep in mind your cosine graph as well. The cosine of 0 is 1. Okay, the next one we're going to do is arc cos of negative 1. Okay, so again, cosine of what angle is equal to negative 1? And hopefully you are able to tell me that that would be pi. All right, let's try arc cos of 1/2. So cosine of what angle equals 1/2? Hopefully you know that's 60 degrees, and so that would be pi over 3. And what if I were to ask you the arc cos of negative 1/2? Okay, well you can see negative 1/2 here. If we were to come up and follow that along, that's going to be right here, which is in the second quadrant. It's somewhere between pi over 2 and pi. And so we know that arc cos of 1/2 is pi over 3. So if I were to reflect that angle into the second quadrant, I would get 2 pi over 3. The last graph that we're going to take a look at is y equals arc tan x, or y equals inverse tan x. This one does happen to be the AP's favorite, and so we definitely want to make sure that we know it, that we know what it looks like, and we are able to evaluate it. So the domain here, this is different. Domain and range are going to look different for your arc tan, and part of that is because of the horizontal asymptotes, and just because of the way that y equals tan x looks very different than sine and cosine. So our domain here is all real numbers. It goes from negative infinity to infinity. And our range this time is not inclusive. It is from negative pi over 2 to pi over 2, but because of those horizontal asymptotes, we are using parentheses to enclose that, not brackets. Because, of course, we will never reach a height of pi over 2 or negative pi over 2. Okay, so let's just evaluate a couple of these. If I were to say the inverse tan of 1. So again, what the tangent of what angle is equal to 1? Well, you might remember that in order for it to equal 1, because tangent is equal to sine divided by cosine, you would have to be looking for the point on the unit circle where sine and cosine of that angle were the same. Okay, if you use our graph to kind of help us with this, if we look at where 1 is here, when x is 1, you can see that that happens right about here, which you can see is about halfway between 0 and pi over 2. And in fact, you may be remembering that the inverse tan of 1 is an angle of pi over 4. And then if I asked you for the inverse tan of negative 1, well, that would be right here, which would fall right here, which again would be halfway between now 0 and negative pi over 2, so it's negative pi over 4. Okay, now it's time to get started on some new stuff here. The derivatives of inverse trig functions. There are 3 formulas that you must memorize. So let's make sure that you get these down in your notes, and then I would pause the video and I would get out some flashcards and get these memorized. These are great power quiz questions. These are great questions that you need to know for sure the formulas for these. So we've learned some new formulas over the last several classes. We've learned the derivative of exponential functions, the formula for derivative of logarithmic functions, and we've learned the formula for derivative of inverse functions. And now we have 3 more, the derivative of inverse trig functions. Okay, the first one is the derivative of arc sine u, where again u is a function in terms of x. And so the derivative of arc sine u, again we have to memorize this, is du over square root of 1 minus u squared. Okay, move on to the next one. The derivative of arc cos u, or inverse cos u, would be negative du over the square root of 1 minus u squared. So those look very similar. Obviously, the big difference is that sine is positive and cosine is negative. That should not be a stretch for you to memorize, because remember, the derivative of sine is positive and the derivative of cosine is negative. So that should hopefully help with the memorization of those two. All right, what about the derivative of arc tan u? That is du over 1 plus u squared. Of course, you'll notice that that one looks a little bit different because it does not have the square root. So that might be the way to differentiate that one from the other 2 formulas. Okay, we're going to go ahead and find the derivative of the given function. So the first one we're going to do is y equals arc sine 2x. We always want to go ahead and understand and make note of what our u is. So here our u is 2x. And then I also go ahead and tell me what is du. So the derivative of 2x obviously is 2. All right, now that we know that, we're ready to just plug it into our formula. So y prime would equal du, which is 2, over the square root of 1 minus, now this is a place where a lot of students make a mistake, we're squaring u. Well, u is 2x. You need to square the 2 and the x, so this would be 4x squared. And that's it. We don't have to do anything else with it. That is our answer. All right, let's try the next one. Number 2. We'll say f of x is equal to arctan of 3x. Again, we want to identify our u. Here is 3x, and our du as 3. Okay, so the derivative of arctan is du, which would be 3, over 1 plus, again, take your u, which is 3x, and square it, so we'd get 9x squared. And again, that's our final answer. All right, number 3. Y equals arc cos of the square root of x. Okay, so let's identify our u, and as we do that, we want to go ahead and use the exponent x to the 1/2. So we want to rewrite it with that exponent so that we can right away say that our du is 1/2 x to the negative 1/2. Okay, so let's go ahead and put that into the formula. So y prime equals negative du, so negative 1/2 x to the negative 1/2 over the square root of 1 minus u squared. So if I square the square root of x, or if I square x to the 1/2, I just get x. All right, so that definitely needs to be cleaned up because it's not as nice as we would like. So we're going to go ahead and clean that up. Okay, so let's see here what needs to happen. The 2 needs to come down, so we have a negative on the top, and we have a 1. On the bottom, our 2 is going to come down. X to the 1/2 here, x to the negative 1/2 is going to come down, and it's going to come down as a square root of x. And then, of course, we already have the 1 minus x, the square root of 1 minus x down there. All right. Can that be cleaned up anymore? Yes, in fact, it can. If you remember how to multiply radicals, all you do is multiply what's underneath the radicals. So I'm going to keep my 2 out in front, and I'm going to multiply what's underneath. And so the final cleaned up step would be the square root of x minus x squared. And so that would be the derivative in simplest form. Okay, we're going to try one more. So let's go ahead and do number 4. And we're going to write this as g of x is equal to natural log of 1 plus x squared plus inverse tan of x. Okay, so we have 2 different things that we have to take the derivative of here, and of course linked with a plus sign. So we're going to go ahead and do g prime of x. All right, remember that the derivative of a natural log function is du over u. So in this case, our u is 1 plus x squared. The derivative of that would be 2x over 1 plus x squared. Plus, now, the derivative of inverse tan of x, well, here we have a new u of x. The derivative of that is 1 over 1 plus u squared, so 1 plus x squared. Okay, you hopefully noticed that you do have a common denominator of 1 plus x squared, so we can just add our tops here, 2x plus 1 over 1 plus x squared. And that is the derivative. Okay, we have one last question to do, one that we should be very familiar with answering. Find the line tangent to the function at the given x value. All right, so we're given this x value and we're given this function. Of course, we need 2 things. We need the point and we need the slope. So we're going to go ahead and find the point. Y is equal to arc cos of e to the 2 times 0 would just be 0. So, of course, that would be y equals arc cos of 1. All right, so let's think this through. This is asking us the cosine of what angle equals 1, and hopefully you are able to say that would be an angle of 0. Cosine of 0 is 1. All right, so we know our y value is 0 and our x value is 0, so we're talking about a point of 0, 0. Next, of course, we need to take our derivative in order to get our slope. So if I look at this, I need the derivative of arc cos e to the 2x, which of course is negative du over the square root of 1 minus u squared. So I need to know my u, which in this case, of course, is e to the 2x, and I need to know my du. So the derivative of an exponential function is the exponential function times the derivative of the exponent, which would be 2. All right, so I'm going to say y prime is equal to negative 2e to the 2x over the square root of 1 minus my u value squared. Okay, when you square power, you multiply the exponent, the current exponent, by 2. So it would be e to the 4x. Okay, so that's my slope, that's my derivative. Now I need to go ahead and evaluate that at 0. So I have negative 2 e to the 0 over the square root of 1 minus e to the 0. All right, so hopefully we know that e to the 0 is 1. So we end up here with our slope is negative 2 over the square root of 1 minus 1 is 0. So that ends up with an undefined slope. What does that mean if you have an undefined slope? That means that we have a what kind of line? A vertical line. Okay, so this is telling me that my line tangent to the given function at x equals 0 is a vertical line. Vertical lines all have the equation x equals, and what is my x value? 0. So the equation of the line is x equals 0. That's the equation of the line tangent to y equals r cos e to the 2x at x equals 0. Okay, ladies and gentlemen, I don't think that those derivatives are hard in any way, shape, or form, but it's just about memorizing those 3 new rules and making sure that you have those down pat by the next class. I would also say that it's really important for you to know your inverse sine, cosine, and tangent graphs, as well as how to evaluate those inverse trig functions for given different values to find their angles. So thanks so much for listening. Please make sure you get that stuff memorized, and I will see you next class.